We are pouring massive amounts of capital into large language models, but enterprise deployment is currently an exercise in chaos. You get immense computational power, but without a physical structure to contain it, that engine eventually vibrates until it shakes itself apart. This grid represents a stark reality found in recent empirical data. When exposed to real-world enterprise environments, 95% of generative AI pilots fail outright. These failures occur because raw language models lack an operating system to direct their logic. Relying on a raw, probabilistic while loop in a production stack creates enormous financial risk. To survive edge cases and prevent unguided hallucinations, you require a layer of engineered software containment. Foundational model intelligence is only useful if you have the rigorous systems engineering required to steer and constrain it. The fix is a framework called the agent harness. It provides strict, non-negotiable operating constraints required to turn a volatile engine into a production-ready machine. That containment structure begins with the H, standing for handoff or intent routing. This radar-style display shows how intent routing operates like a digital air traffic controller. Instead of letting one generalist AI agent guess its way through every user query, a hybrid cascading router takes control of the incoming traffic. The router uses zero-cost rules to scan incoming requests. If a task is simple and unambiguous, it is sorted away from the main processor and resolved instantly by deterministic code. Complex, ambiguous queries are isolated and routed exclusively down a reinforced path, reserving expensive, heavy-duty reasoning tokens for the problems that actually require them. This dual routing protocol stops the system from relying on a single agent to guess its way through tasks it isn't equipped to handle. Filtering out the noise provides two physical benefits. Simple tasks resolve in milliseconds via rules, and your token budget is preserved for the heaviest queries at the core. Strict intent routing is the defining architectural difference between a fragile prototype that guesses and a resilient system that decides. But the handoff routing hub is only the first layer. Sustaining an autonomous agent over time requires a broader infrastructure of checks and balances. The A and R components, agent orchestration and React planning, turn a prompt into a step-by-step navigation map, allowing the model to observe its progress and correct course. The N and E layers use a network of middlewares to filter every function call, while evaluation loops judge the output against a hard rubric before it ever reaches the user. Finally, the two S's, safety breakers and sustained iteration logs, monitor for repeating patterns and API failures, cutting the power if the logic starts to spiral. These 6 layers snap together to form a structural cage that prevents the model's probabilistic output from destabilizing your production environment. If a deployment is missing even a single one of these components, the agent remains exposed to spiraling edge cases and catastrophic logic failures. To understand what these logic failures look like in practice, we can look at a stark enterprise incident from 2025. An engineering team deployed an agent without a harness. When faced with an unexpected API response, the model fell into a runaway, self-executing loop. Because there were no evaluation loops or safety breakers to interrupt the cycle, the agent autonomously burned through $47,000 in API costs in just 11 days. If that agent had been wrapped in a harness, the middleware would have recognized the repeating state, triggered an automatic circuit breaker, and frozen the financial burn instantly. The lesson is clear. The practice of deploying raw, probabilistic while loops in production must end. To move beyond the prototyping phase, you must strap on the operational harness and enforce strict intent routing. In the era of autonomous workflows, the survival of an enterprise does not depend on the intelligence of its AI. It depends on the strength of the mechanical containment structure you build around it.